look at solving systems of equations using the elimination method. To solve systems of equations, we're working with two different equations. The first thing that we want to do when solving systems of equations is look for any pair of the variables with coefficients that when added together will cancel each other out or equal 0. So in this example, we see that there is a -6 and a +6. Those when added together will create 0. Therefore, we can eliminate the x variable. So when we see this relationship, we can immediately go and add these two equations together, cancel out the x's, add the 5y, the 4y to get 9y, add the 1 and the -10 to get -9, and then we can solve for y. To this, we divide each side by 9 and get y to equal -1. Now, because we're solving a system of equations, we want to solve for both x and y. Now that we have a value for y, we can choose either the first or second equation, doesn't matter which one, and substitute the value for y back in to solve for x. So let's take the first equation. -6x plus 5y equals 1. Now, since we have a value for y, that's -1, we substitute that value in. So we get -6x plus 5 times -1 equals 1. Now we're going to solve for x using our two-step equation solving method. -6x, 5 times -1 equals plus -5 equals 1. Now I'll draw a line down the center, down the equal sign, and I'll see a -5, or plus a -5. So to get rid of that, I add a +5. If I do it to one side, I have to make sure I do it to the other side. That will go away, and I get -6x equals 1 plus 5 is 6. Divide by -6, divide by -6, and I get x to equal -1. So I have x equals -1, y equals -1. I write my answer in a coordinate pair to be -1, -1. The next example we'll look at is an example where we have to multiply one of the equations by a number. First, we look for a relationship that could be easy to multiply and get rid of a variable. Here we see a y and a y. That would be easy to get rid of. So what we're going to do is we're going to multiply either equation. So we'll just choose the top equation by -1. By doing this, we'll get a new equation of -x, -1 times 8x, -1 times +y will give me a -y, and -1 times -16 will get me a +16. I will then copy down the second equation of -3x plus y equals -5. Now I can combine these two equations and eliminate the variable of y. Once I see a plus y, and a minus y, I know I can eliminate. So I'm going to add these two equations together. The y's are now going to cancel out and go away. So -8x plus -3x, we get -11x. 16 plus a -5, we get 11. To solve for x, I divide by -11. Divide each side by -11. That's going to go away. X equals -1. Now again, because this is a system of equations, we want to solve for x and y. So to solve for y, we're going to substitute the value for x back into one of these equations. It doesn't matter which one. So again, we'll choose the first one. So we have 8x plus y equals -16. Now instead of x, we'll put the value of x, which is -1 in. So we'll take 8 times -1 plus y equals -16. 8 times negative 1 is negative 8, plus y equals negative 16. We'll add 8 to each side. Add 8 to each side. That will go away. We get y equals negative 8. So a solution to this system of equations is x equals negative 1 and y equals negative 8. So our ordered pair, or coordinate pair, is negative 1, comma, negative 8. That is our answer. One final method we'll look at is when we have to multiply both equations by a number. Now this happens, we could always do this. This method will never fail. But we could also do this if we don't see any kind of relationship. Now in order to do this, we're going to multiply each equation by a number. My method for doing this is to take each of the coefficients of the x. So take the 5 and the 3. We'll take the 5 and we'll put it in front of the opposite equation. We'll take the 3. We will put it in front of the opposite equation. So the 3 goes to the top and the 5 goes to the bottom. Now the key thing is these have to be different signs. If they're already different signs, great. If not, like this case, we have to make one of them negative. Does not matter which one. Now we will distribute this number, multiply it by each of the terms in the equation. We'll get a new equation. Negative 3 times 5x will get us negative 15x. Negative 3 times 4y will get us negative 12y. Equals negative 3 times negative 30 will get us positive 90. We'll do the same thing for 5. Multiply the 5 by each individual term. 5 times 3x will be positive 15x. 5 times negative 9y will be negative 45y. And 5 times negative 18 will equal negative 90. Now we're ready to combine and eliminate these two equations. We're going to combine them to eliminate the x values. So we add these two equations together. Negative 15x and positive 15x will cancel out and go away. Negative 12y and negative 47y will add together to be negative 57y. Positive 90 and negative 90 will add together to be 0. Divide each side by negative 57. Divided by negative 57, I get y to equal 0. Now once again, we have to make sure that we solve for both x and y. So we take either of the equations. Again, we'll take the top equation, 5x plus 4y equals negative 30, and we will solve for x. Take our value of y of equal to 0, substitute that back in for y. So we'll have 5x plus 4 times, now the value of y is 0, equals negative 30. So we simplify, 5x plus 0, so that's going to go away, equals negative 30. To solve, we divide each side by 5. Divide each side by 5, and x equals negative 6. So our solution to those systems of equations is negative 6, 0.